Please like, subscribe, and put on your notification. Thank you.
Hello everyone, good day to you. My name is Tutelage. Welcome to Tutelage Educational Services. I am a mathematics teacher and I'm taking us a very important topic which we call fraction. That's fraction. Alright, so when we talk about fraction, we actually need to understand what a fraction is. So let's say, what is a fraction basically? A fraction is just, say, having a half or a part of a whole. So if this is a whole, for example, if we have this square and we divide it into some parts, probably, let's say, here we have 1, 2, 3, 4, 5, 6, 7, 8. 8 parts in that box. If I'm to shade a number of parts, let's say I'm shading 3 parts of the whole fraction. If we remember the total amount of boxes I have here, the fraction was divided into 8. So how many parts did I shade? 1, 2, 3. We have a 3. So if you have something like this, 3 over 8, like we all know of, you can also say 3 out of 8. 3 out of 8. That gives me 3 over 8, like we know about fractions. So now we're going to go into the types of fraction that we're having and the properties of fractions. Alright, as you can see from the fraction I have here, there is a number up, there is a line here, and there is another number below. So the line here would be called our divisor. The number above is called the numerator, and the number below is the denominator. Alright, so now moving to types of fractions. So we have the proper fraction, we have the improper, and we have the mixed fraction. And their examples. So number 1, we have the proper fraction, like I said earlier. And for the proper fraction, your numerator is less than the denominator. So an example of a proper fraction is when you're having 2 over 5. The normal way I do teach this is I'll tell you, okay, 2 is a smaller number, 5 is a bigger number. When you place a smaller number on a bigger number, it is good. Like, the bigger number can efficiently carry the smaller number. But now let me talk about the second type of fraction. We have the improper fraction. So for the improper fraction, here the denominator is actually less than the numerator. So for example, we could have, let's say, 7 over 4. As you can see here, 7 is a bigger number than 4. So it is not proper for something big to be resting on something small. So that's why we call it an improper fraction. But for the proper fraction, the small number is on top, and it is proper for the smaller number to be on the bigger number. So the third type of fraction that we have is the mixed fraction. And for the mixed fraction, we have a whole number and a proper fraction. So we're having, for example, 4 whole number, 5 over 7. What's it called? So we have, this is the whole number, and this is a proper fraction. So this is a whole number, that's the 4, and 5 over 7 is a proper fraction. So the both together gives you a mixed fraction. Alright, so we also have other types of fractions, other properties of fractions. Let's just say other aspects of fractions now. So for the first one, we have what we call the like and unlike fractions. Alright, so for the like fractions, so those are the fractions with the same denominator. So fractions with the same denominator is called, or they are called like fractions. So for example, you can have 4 over 9, 3 over 9. They have the same denominator, that is 9, and that makes them like fractions. Then for the unlike fractions, so those are the fractions with different denominators. So now examples, we have 3 over 6 and 1 over 5. As we can see, the denominators here are different. We have different denominators. We have 6 and we have 5. They're not the same number. Other properties of fraction that we also have the equivalent fractions. These are equal fractions. Yeah, you can have a fraction appearing in 2 or more different ways, but it will still give you the same value. So for example, if I have 1 over 3, I have 1 over 3, and I have another number like, let's say, 4 over 12. The two fractions are the same, and this is the way we know when they are the same, and or how to get this fraction, how to get an equivalent fraction. So this is what we do. We just pick any number randomly and multiply the numerator and the denominator by that same number. So let's say my equivalent number is 3, for example. So when I say, oh sorry, I have to put that back. So my equivalent number is 4. So what I'm going to do now is this 1 multiplied by 4 over this 3 now multiplied by 4. That's going to give me 4 over 12. That is the way I got that equivalent fraction for 1 over 3. I can get another equivalent fraction still using the same fraction, but I'll change my equivalent number. So in my equivalent number now equals, let's say, 2, for example. So I'm going to have 1 times 2 over 3 times 2, and that will give me 2 over 6. So the fractions I have now, I have 1 over 3, 4 over 12, and 2 over 6. They are all the same thing, and that's where we came across the equivalent fraction. Alright, now we're going to the addition and subtraction of fractions. Addition of subtraction. So I'll be taking just a few examples. So now I'm starting with like fractions. I have explained to us what I mean by like fractions before. So now examples of this, if I'm having 3 over 7 plus 2 over 7. If we look closely, I have the same denominator for both of them. 7 here and 7 here. So what we just do is this. We draw a long line like that. After drawing that long line, you pick just one of the denominators. That's what 7. Since it's the same thing, you write it there. And the next thing you do is you pick the two numerators and the symbol in between. So when you pick 3, you write your plus, then your 2, and you solve. So 3 plus 2 gives us what? 5/7. So that's how you add like fractions. When you come down to unlike fractions, for example, you have 4/9 plus 2/, let's say 5, for example. If you look closely, the two denominators are different. So this gives us unlike fractions. So for this fraction, what we're going to do is we're going to look for the LCM of 9 and 5. Look for the LCM of 9 and 5. Let's quickly take us on how to find the LCM of 9 and 5. You have 9, you have 5, then you have the divisor. LCM. What's the least prime number that can go in any of these two numbers? That's 3. 3 goes in 9 how many times? 3 times. Can 3 go in 5? No. So you write your 5 down. We do the same thing here again. What's the lowest prime number that can go in both? You have 3. So how many 3 can you find in 3? You have 1. Can 3 go in 5 completely? No. So you write your 5. What do we do next? The next prime number to divide is 5. So if I have a 5 in 1 here is still going to be 1. Then how many 5 can I get in 5? 5 divided by 1, 5 is what? 1. So I pick the values I have here. Multiply. So I have 3 times 3 times 5. 3 times 3 gives us 9. 9 times 5 gives us 45. So this is my LCM. Now bring this down. You roll your line again like you did here. It is this LCM that you would bring here. That gives you what? 4 and 5, 45. So what you do now is this. You come back to this denominator. Now you divide the LCM by this denominator. So 45 divided by 9 gives us what? 5. So this 5 becomes an equivalent fraction. You multiply this 5 by the numerator, which is 4. So 5 times 4 gives us what now? 20. You have a symbol plus. You do the same thing for 5. So 45 divided by 5 gives us 9. Gives us 9. So 9 now multiplied by 2. So times 9 gives us what? 18. You put that here. So if you add up both 20 plus 18 gives us what now? That's 30. Don't worry.
Okay.
Alright, now so we have 20 plus 18 now gives us 38/45. And that's our final answer. So when we're adding like fractions, remember you just pick one of the denominators and place it. Pick your numerators, add them together, and get a final answer. The same thing happens when you are dividing as well. When you are subtracting. The same thing happens when you are subtracting as well. Whatever symbol you're having in the middle. So if it is minus you're having, okay, don't worry. 3 plus 2 now gives us what? 5 over the same denominator 7. For unlike fractions, you find the LCM of the both denominators, 45. You divide the LCM by the first denominator. Whatever value you get, you multiply it by the numerator. The same thing happens for the second fraction. You divide the LCM by this denominator. Whatever value you get, you multiply by the numerator of the second fraction. After getting both, you add them up. Your answer is being written that way. For the like fractions now, let's say I'm having 7/9 minus 4/9. The same thing we did here is what we're going to apply there. You draw the divisor first. This long line you have is called the divisor. Your LCM, your denominator, the common denominator, which is 9. Then you have your numerator, just write them out, 7 minus 4. I am doing this because the both of them have the same denominator. Alright, so 7 minus 4 gives us what now? That's 5/9. Good, therefore, unlike fractions, Alright, then having 9 over 10 minus, let's say, 2 over 7. Alright, if you look closely, we find out that both of the fractions have different denominators. They have different denominators. So what I'm going to do here is this. I'll look for the LCM of 10 and 7. Let's go. LCM 10, 7. Alright, so this is what I'm going to do. What's the least prime number that can go in the both of them? That's, I have 2. 2 can go in 10. Sorry. What's the least prime number that can go in any of the both of them? So I have 2. 2 can go in 10 5 times. 2 cannot go in 7, so you write out your 7. You draw your line again. The least prime number that can go here is what? 5. 5 in 5 is what? 1. 5 in 7 cannot go, you write your 7. Then the final number you can use to divide here is 7. Bring your 1. The 7 in 7 is what? 1. So I have my times. So 2 times 5 times 7. So 2 times 5 gives me 10. 10 times 7 gives me 70. So my LCM here is what? 70. Now back to the way we treated this. So we're having, back to the way we treated this, we'll be having 10. Now you're going to use 10 to divide 70. So 70 divided by 10 gives us what? That's 7. Then you multiply 9 by 7. 7 in 70, you have 10. You multiply 2 times 10. So 9 times 7 will give us 63. Minus 2 times 10 gives us 20. Now when you take away 20 from 63, you get what? 43 over 70. And that's our final answer. Thank you very much and have a lovely day. See you next time.